Hello and welcome to Intro to C. I am Bill, and today we're going to learn about constants, or more specifically, integer and number constants, and only the basics. So when we declare variables normally, like especially integers, like int, let's say Frank, I'm going to keep it actually A, just to make it simpler, int A, and we assign like 1, 2, 3, 4 to it. This actual number here is actually of integer type as well. So if we wanted a long type, long integer or long int, like b, if we wanted to specify the type there, we need to put something, a prefix on the end. So this would then become like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, L. Now this L at the end, capital or lowercase, it doesn't matter, specifies that this actual number here is of long type. Now the reason why is if you were writing a number that you wanted to be of size long, then that is what you've got to write. So you may have written a number that won't fit into a int, but it may fit into like a long, depending on your platform and compiler, then that's the way you got to do it. If you were going to write a long, so long, let's say C, then you've got to do the same thing again. But the prefix in this case is LL or LL, and that specifies it being a long. If you wanted to write an unsigned constant, the way you do that is you actually use a U as the suffix. So for an unsigned, let's say UA, so unsigned int, what you could do 1, 2, 3, 4, and then you write a U at the end, lowercase or uppercase, it doesn't matter in this case. Oops, U. For an unsigned long, you can probably guess you write 1, 2, 3. I'm just going to write 1, 2, 3, 4 in this case. Unsigned long, so UL. Or uppercase, it doesn't make a difference in this case. And that indicates that this constant here that you've hard coded into the program is an unsigned long. And again, the same again is true for an unsigned long. You can just do that. So 2 L's or ULL. Whichever you use, please be consistent. It'll just be easier for you to read. And I usually prefer to write the lowercase version myself. This font that I'm using isn't very clear between 1s and L's, but it does make a difference. I'm just using the default font within Visual Studio. Now, for floating point constants, they must contain a decimal point. So I'm just going to go down here and write another variable. So float x in this case. And they must contain a floating point number. So 123.4. This means it's a floating point number. Now, if it's of single precision, you must suffix it with an F. So this integer constant, or this floating point constant, is now a floating type. If you want one of double precision or double, then you just remove that suffix. If you wanted a long double, then you've got to put an L on the end. So long double Z equals 123.4 L. So now with an F, it specifies its single precision float. Without an F, it's double precision. And with an L, it's a long double. Yeah? And again, these can be uppercase as well if they needed to be. It doesn't make much of a difference. Be consistent when you write them. I like doing it all lowercase. Now, floating point numbers can also be written with like an exponent. So if you're used to like scientific notation like 2.3 times 10 to the power of 7 or something, you can do that in floating point numbers. So I'm going to write down here, I'm going to call it float, and I'm just going to call it XC now. I'm just writing up names, making up names. XC. Now, if I wanted to write a single precision exponent, I could write 1.3 e to the minus 2f. So what this is saying is, take 1.3, then times it by 10 to the minus 2. This is what that e means. It means exponent, and suffix with f. If we take the same, again, I'm just going to copy and paste this, change that to be a double, and then that's a long double. That's y, that's z. We can just remove the prefix and put a prefix on that. And that's how you do exponents. So if I highlight over this variable here, it says this is a floating point type of 0.013 ignoring some of the numbers at the end. Ignore them for now. Later on in the series, I'll explain why it's got some extra numbers on the end. Then for double, it says it's 0.1, 0.012, well, it's 0.13, okay. Again, not exact, but I'll explain that why it's not exactly the right number. And long double is the same thing again. It's about 0.013. Yeah? That's how it does it. So they are your number constants. Now, these are all in base 10. And sometimes you may want to write in a different base. Now, C allows us to write in 2 extra bases, octal and hexadecimal. So the base that we normally write in is base 10. That means we have numbers from 0 to 9. If we used octal, then we only have 8 numbers to deal with, so that's 0 to 7. If we use an hexadecimal, we've got numbers from 0 to 15. So if we were writing, I'm going to get rid of all these now to get rid of, I'll go down a little bit here. So I'll go back to an int. And this is going to be octal. I'm going to call it octal here. Yeah? So to write an octal number, you have to put a leading 0 at the beginning of the integer. And this means this is going to be an octal number. So if I write 0, 1, 2, 3, this is going to have an octal number. So it's going to have 3 units, 2 8s, 1 64th. And if we hover over that, in decimal, 1, 2, 3 in octal is actually a decimal, it's 83. That's what it means. And Visual Studio, if you hover over the number, it actually will tell you what it is luckily, because it's a constant. Now, if we put a 9 in there, this will not work. And it's going to throw us a little error, because this 9 is not a digit in the octal numbers. If you want to learn about more number bases, please read up online, or in books or so on and so forth, and learn about it. So that's how you write an octal, and that is sometimes useful. But on modern computers, this is not as useful. The more useful type of writing numbers is what is called hexadecimal. So I'm going to write hexadecimal. And from the name, you might be able to guess that hex means 6 and decimal means 10. So this is base 16. So to write numbers in hexadecimal, we need to prefix it with a 0x or a 0 capital X. Again, I prefer to use lowercase because I like to have the consistency. And then if I was going to write the number, let's say the number 31 in decimal, in hexadecimal I'd write it as 1F. So I'm going to write the number 31 again in octal here, so we'd all got the same kind of thing going on. So these are all decimal 31. So these are all the same number having different representations. So you may be asking me, with hexadecimal, we've put a letter in there. What's going on? Well, because in normal keyboard language, we've only got 0 to 9 as our characters. We needed to add some more on. So all we did was went from A, B, C, D, E, and F. That's all we did. So the character sets allowed for decimal numbers is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The character set allowed for octal is 0, 2, 1, 2, 3, 4, 5, 6, 7. Remember there's 8 numbers there. And then the character set allowed for hexadecimal is 1, 2, 3, 4, 5, 6, 7, 8, 9. We've run out of numbers, so let's add some more. A, B, C, D, E, F. Very useful. Now, you can only use these 2 for integer types. You can't use these in floating point. So again, we can also apply the same suffixes to all of these as well, the integer types. So if we wanted to make sure that these were a long, we could put an L on the end. To make sure it's an unsigned, we could put a U on the end. If it's unsigned long, you can do that as well. They all apply there. So those are all your number constants. I'll come talk about character constants later on in the series when we talk about strings. So stay tuned for that. And the next episode we'll be talking about arithmetic operators. So thank you for watching and have fun programming.